Oh, hello guys. Today we will try to use Terraform to create a resource in Kubernetes cluster. As we all know, the Terraform can create a resource in GCP, can create a resource in a lot of cloud service providers, but it can also create a resource in Kubernetes cluster. Now I'm using the Quick Labs to quickly start a temporary project to try this out. And before we try it out, we can enter the credentials provided by the Quick Labs, and we enter the credential in GCP to activate the needed functions. And also, in the meanwhile, we can use the Cloud Shell. The Cloud Shell is a very convenient tool to be used in running some command line without even creating the VMs. Okay, let's run it. So we have to run the command line provided by the Quick Labs. First, we can copy the Terraform code from the buckets provided by the Quick Labs. In the Cloud Shell, we can run those commands. Okay, let me activate again because it's a long time inactivated. Let me create. Okay, we have downloaded the Terraform code. Okay, so there are two Terraform files. One is this main.atf files, which is the Terraform code, and in this Terraform code we will create the network and subnetwork. The subnetwork will enable the private Google access, which will allow the Kubernetes service to create a load balancer in the GCP, because you know that when we create a load balancer in GCP, we have to call the Google API. So that's why we have to enable the private Google access. Okay, the second file is to create a Kubernetes resource in Kubernetes cluster, and the first one is you can see that we're gonna use the Kubernetes provider. These are some basic snippet of code to create the resource in the basic Kubernetes cluster. We don't need to modify it. We keep it as is. This is some basic credential, I believe. Okay. Okay, then we have to put our service in a namespace, so we have to create a namespace. The namespace is named the staging, and the Google computer addresses, which means we have to reserve a public static IP address for the load balancer. We will use it in the below snippet code. It will after running of the Terraform code, it will create public IP address. Okay, this is the service of the Nginx. Which namespace it is in? What kind of selector? Do we need to enable the session affinity? What kind of mechanism the session affinity is using? And what is the port of the service? Actually, what is the port of the load balancer? Okay, now you see here the load balancer IP is what I mentioned earlier. Is what we reserved from public IP address. Okay, this part. Yes. The next one is this one is this replica set, which is object of replication controller. This is what is service behind the load balancer. What the image we want to use. How is the CPU and the memory. And at last we have to print out a load balancer IP so that we can access it, we can test it out. Okay. Okay, we are about to run terraform code. Before we run terraform command line, we have to make sure the authentication is okay, because terraform is actually using the G Cloud, the Google Cloud credentials. Now you can see the credentials is the account. The account has been activated since within the Cloud Shell. Okay, we'll run the command. Init will download the providers from Terraform central registry, and then we will run apply. This can take a while because it will create the Kubernetes cluster as well as the Kubernetes resource in Kubernetes cluster. So it will take a while. Let's wait. That cluster is being created. After, you can see now it's finished, and it will create a service in this tab. After click on this tab, this has an Nginx service, and it has an endpoint, which is the IP and the ports. We can directly click on it, and you can see that we can access it. It's working, and workload is here in this tab, and it is a replication controller. In the staging namespace. And the service actually, because the service is a type of load balancer, it will create a load balancer in the cloud platform in the GCP. So when we click on the load balancer, you can see this is a GCP load balancer, And the GCP load balancer is composed of front end and back end. Front end is a IP ports global public IP address. You can see the IP address is what we reserved earlier in the Terraform code. And the backend is some backend in the nodes within the GKE itself. Okay, it's working. So we have confirmed that Terraform can not only create